Grounding bushings are required inside the transformer and panel even if the flex and fittings are listed for grounding. The conduit system provides a continuous path for grounding. The grounding bushings ensure a proper electrical connection between the conduit and the equipment it connects to, which includes the transformer and the panel. This is necessary for the following reasons. Firstly, safety. The bushings provide a low impedance path for fault currents, which prevents electrical shock and equipment damage. Secondly, code compliance. Article 250.86 of the National Electrical Code requires that conduit systems be grounded at all points where they enter an enclosure or box. Thirdly, electromagnetic interference mitigation. A properly grounded conduit system helps to mitigate EMI by providing a shielding path for electrical noise. In some cases, grounding bushings may not be required if the transformer or panel has an internal bonding jumper that connects the conduit to the ground busbar. However, this is not common practice and should only be done in accordance with the manufacturer's instructions and applicable codes. Therefore, it is recommended to install grounding bushings in the transformer and panel to ensure a proper and safe grounding connection. To expand on the safety aspect, imagine a scenario where a fault occurs within the transformer. Without a proper grounding path, the fault current could travel through unintended paths, such as the metal enclosure of the transformer or the conduit itself. This could lead to a dangerous voltage potential on these surfaces, posing a significant risk of electrical shock to anyone who comes into contact with them. Grounding bushings, in conjunction with the grounding electrode conductor, provide a direct and low impedance path for the fault current to flow back to the source, tripping the circuit breaker or fuse and quickly de-energizing the circuit. This rapid clearing of the fault minimizes the risk of electrical shock and equipment damage. From a code compliance standpoint, Article 250.86 of the National Electrical Code is very specific about the requirements for grounding metal enclosures and raceways. This article mandates that metal enclosures and raceways be made electrically continuous and bonded to ground. Grounding bushings are one of the primary methods used to achieve this bonding. By installing grounding bushings at the point where the conduit enters the transformer and panel, you are ensuring that the conduit system is effectively connected to the grounding system, providing a reliable path for fault currents. Ignoring this requirement can lead to code violations and potential safety hazards. Considering electromagnetic interference many electronic devices are susceptible to EMI, which can disrupt their operation or cause them to malfunction. Electrical noise generated by transformers and other electrical equipment can propagate through the conduit system, creating interference that affects nearby sensitive equipment. A properly grounded conduit system acts as a shield, preventing this electrical noise from radiating into the surrounding environment. Grounding bushings play a crucial role in maintaining the integrity of the shielding, ensuring that the conduit system is effectively grounded and able to suppress EMI. While it's true that some transformers and panels may have internal bonding jumpers that connect the conduit to the ground busbar, relying solely on these internal jumpers is not always sufficient. The quality and reliability of these internal jumpers can vary, and they may not always provide the same level of grounding performance as a properly installed grounding bushing. Additionally, internal jumpers may not be accessible for inspection or maintenance, making it difficult to verify their effectiveness over time. Therefore, it's generally recommended to install grounding bushings in addition to any internal bonding jumpers to ensure a robust and reliable grounding connection. The size of the grounding bushing and the grounding electrode conductor are determined by the size of the overcurrent protection device protecting the circuit. Consult the National Electrical Code Table 250.122 to determine the appropriate size of the grounding electrode conductor based on the size of the overcurrent protection device. The grounding bushing must be sized to accommodate the grounding electrode conductor. Additionally, the type of grounding bushing used will depend on the type of conduit being used. For example, for rigid metal conduit (RMC) or intermediate metal conduit (IMC), a grounding bushing with a set screw is typically used to ensure a secure connection to the conduit. For electrical metallic tubing (EMT), a grounding bushing with a compression connector is commonly used. It is critical to inspect the grounding bushings regularly to ensure they are in good condition and properly connected. Over time, corrosion or loose connections can compromise the effectiveness of the grounding system. Regular inspections can help identify and address any potential problems before they become safety hazards. In addition to the grounding bushings, a flexible metal conduit itself must also be properly grounded. While listed flexible metal conduit fittings are designed to provide a grounding path, it is still essential to verify the continuity of the grounding path. This can be done by using a multimeter to measure the resistance between the conduit and the grounding electrode. A low resistance reading indicates a good grounding connection. It is also important to ensure that the flexible metal conduit is not damaged or kinked, as this can also compromise the grounding path. The length of the flexible metal conduit run should also be limited to minimize impedance. Longer runs of flexible metal conduit can have higher impedance, which can reduce the effectiveness of the grounding system. The National Electrical Code specifies the maximum allowable length of flexible metal conduit runs based on the size of the circuit. In addition to the National Electrical Code, local electrical codes may also have specific requirements for grounding electrical systems. It is essential to consult with a qualified electrician or electrical inspector to ensure that your electrical system complies with all applicable codes and regulations. Remember, proper grounding is essential for electrical safety and equipment protection. By following the recommendations in this video and consulting with qualified professionals, you can ensure that your electrical system is properly grounded and safe. When installing grounding bushings, be sure to follow the manufacturer's instructions and use the correct tools. Over-tightening or under-tightening the set screws or compression connectors can compromise the connection. Use a torque wrench to ensure that the connections are tightened to the specified torque. When working with electrical systems, always energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. Working with electricity can be dangerous, and it is essential to take all necessary precautions to protect yourself from electrical shock. Finally, document all grounding connections and measurements. This documentation can be helpful for future troubleshooting or maintenance. Keep a record of the size and type of grounding bushings used, the size of the grounding electrode conductor, and the resistance measurements of the grounding path. This information can be invaluable for ensuring the continued safety and reliability of your electrical system. Let's delve deeper into specific scenarios. Imagine a large industrial facility with multiple 480/277 volt panels feeding various pieces of equipment. Each of these panels will likely have multiple conduit runs exiting and entering, many of which may transition to flexible conduit to accommodate equipment movement or vibration. In this environment, the importance of proper grounding becomes even more critical due to the potential for high fault currents and the presence of sensitive electronic equipment. Each conduit entry point into these panels and any associated transformers should be equipped with grounding bushings meticulously installed and inspected. Furthermore, regular infrared scanning of these connections can help identify any hotspots caused by loose or corroded connections, allowing for proactive maintenance before a problem arises. Now, consider a commercial building with a dedicated transformer serving a sensitive computer server room. The server equipment is highly susceptible to voltage fluctuations and electromagnetic interference. In this scenario, a robust grounding system is not just a matter of code compliance, but also a critical factor in ensuring the reliable operation of the server equipment. In addition to grounding bushings, the installation of a dedicated grounding electrode system for the server room may be warranted to provide an even lower impedance grounding path. This could involve driving ground rods or installing a ground plate specifically for the server room. Moreover, surge protection devices should be installed at the service entrance and at the panel serving the server room to protect against voltage surges that can damage sensitive electronic equipment. The NEC also addresses the grounding of separately derived systems such as transformers. Article 250.30 outlines the requirements for grounding these systems, which include connecting the neutral point of the transformer to a grounding electrode system. This grounding electrode system must meet specific requirements, such as having a resistance to ground of no more than 25 ohms. If the resistance to ground exceeds 25 ohms, a supplemental electrode must be installed. The grounding electrode conductor used to connect the neutral point of the transformer to the grounding electrode system must be sized according to NEC Table 250.66 based on the size of the transformer conductors. Proper grounding of separately derived systems is essential for ensuring the safety and reliability of the electrical system. In addition to the grounding requirements for the transformer and conduit system, it is also important to ensure that the equipment being served by the transformer is properly grounded. This includes connecting the equipment grounding conductor to the equipment grounding terminal in the panel and to the equipment itself. The equipment grounding conductor must be sized according to NEC Table 250.122, based on the size of the overcurrent protection device protecting the circuit. Proper equipment grounding is essential for providing a low impedance path for fault currents, protecting equipment and personnel from electrical shock. Let's discuss common mistakes when installing grounding bushings. One frequent error is using the wrong size grounding bushing for the conduit. Grounding bushings come in various sizes to match different conduit diameters. Using an undersized bushing can result in a poor connection, while an oversized bushing may not fit properly. Always verify the conduit size and select the correct grounding bushing accordingly. Another mistake is failing to properly tighten the set screws or compression connectors in the grounding bushing. These connections must be tight enough to ensure a secure and reliable electrical connection. However, over-tightening can also damage the bushing or conduit, so it's important to use a torque wrench and follow the manufacturer's instructions. Another common mistake is neglecting to clean the conduit before installing the grounding bushing. Dirt, grease, or corrosion on the conduit surface can impede the electrical connection. Use a wire brush or emery cloth to clean the conduit surface before installing the bushing. Failing to properly bond the conduit system to the grounding electrode system is another critical error. The grounding electrode system provides the reference point for grounding, and the conduit system must be effectively connected to it. This connection is typically made at the service entrance or at the transformer. Use appropriate bonding jumpers and connectors to ensure a low impedance connection. It's important to reiterate that flexible metal conduit, while often used for its flexibility and ease of installation, presents unique challenges when it comes to grounding. While listed fittings are designed to provide a grounding path, their effectiveness can be compromised by factors such as loose connections, corrosion, or damage to the conduit itself. Therefore, it's essential to carefully inspect the flexible metal conduit and its fittings to ensure that they are in good condition and properly installed. When in doubt, it's always best to err on the side of caution and install a separate grounding conductor within the flexible metal conduit to provide a redundant grounding path. This is especially important in critical applications where the reliability of the grounding system is paramount. Understanding impedance is crucial in grounding. Impedance, measured in ohms, is the total opposition to current flow in an alternating current circuit. It includes both resistance and reactance. A low impedance grounding path is essential for effectively clearing fault current. A high impedance grounding path can impede the flow of fault current, delaying the tripping of the overcurrent protection device and increasing the risk of electrical shock and equipment damage. Factors that can contribute to high impedance in the grounding system include loose connections, corroded connections, long conductor lengths, and small conductor sizes. To minimize impedance, use short, direct grounding conductors, ensure that all connections are clean and tight, and use conductors that are sized appropriately for the available fault current. Proper grounding is not just a matter of installing grounding bushings and connecting conductors. It's a comprehensive system that requires careful planning, installation, and maintenance. By understanding the principles of grounding, following the requirements of the National Electrical Code, and paying attention to detail, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and regulations. Furthermore, consider the environmental factors that can impact the performance of a grounding system. In corrosive environments, such as coastal areas or industrial facilities with harsh chemicals, corrosion can quickly degrade grounding connections, increasing impedance and compromising the effectiveness of the grounding system. In these environments, it's essential to use corrosion-resistant materials such as stainless steel or copper for grounding conductors and connectors. Additionally, regular inspection and maintenance of the grounding system are critical to identify and address any corrosion before it becomes a problem. In areas with high soil resistivity, it can be difficult to achieve a low-resistance grounding electrode system. Soil resistivity is a measure of how well the soil conducts electricity. High soil resistivity can make it difficult to establish a good electrical connection between the grounding electrode and the earth. In these situations, it may be necessary to install multiple grounding electrodes or use soil enhancement techniques to reduce the soil resistivity. Soil enhancement techniques can include adding conductive materials to the soil, such as bentonite clay or groundwater. The National Electrical Code provides guidance on the installation of grounding electrodes in areas with high soil resistivity. Finally, remember that grounding is a dynamic process. As electrical systems evolve and change over time, the grounding system must also be updated and maintained to ensure that it continues to provide effective protection. Regularly inspect and test the grounding system to identify any potential problems and address them promptly. Keep accurate records of all grounding system installations and maintenance activities. By taking a proactive approach to grounding, you can minimize the risk of electrical hazards and ensure the long-term safety and reliability of your electrical system. Grounding is not merely a regulatory requirement, it is a fundamental safety measure that protects people and equipment from the hazards of electricity. Understanding the principles of grounding, following the requirements of the National Electrical Code, and paying attention to detail are all essential for ensuring a safe and reliable electrical system. So, always use grounding bushings whenever you transition from E&T to flex conduit. Always.